Okay, so last session of this iteration, and as I said, this one in this iteration we focused mostly one part of the thing, that is asynchronous programming, isn't it? Basically, we're trying to understand what is asynchronous programming and why we're trying this different approach, which is different than our traditional programming, and how it can help us to go beyond the traditional programming, how it can help us to use our CPU core more and can process the request more faster and obviously speed up our application. Reactive application doesn't always mean speeding up, okay? It is like efficiently using all your resources that you have in your server. And here resources means what I am mentioning is about the CPU cost, the threads, the thread pool, okay? Because we have limited number of threads and we need to make sure that we have to reuse all the stuffs, okay? Cool. So right now, let me do one thing. Okay. So let's just do one thing. I think in the last session, I have told you guys a little bit about the Future API. Okay. Because we wanted to do asynchronous programming in Java and we have used Future API. And I also told you we have a advanced version, or a we can say we have a pro version of the Future API is available, and that is CompletableFuture, using what we can overcome. Maybe it's not like overcome the disadvantage of the future. The future already provides us the way to do the asynchronous programming, but as Future has released maybe around 1.5 version of Java, it is not that functional. You cannot write much of functional programming using Future. Whenever we're talking about reactive programming, guys, whenever we're talking about reactive stream, I'm sure if you're following me up from the day one, you understand one thing, that we are writing much of functional programming, right? The lambdas, the streams, and all that. And the CompletableFuture is basically released with Java 1.8 version, if I'm not wrong. In the same version, your stream API and lambdas are also released. So using CompletableFuture, you can also do the asynchronous programming, okay? And like the asynchronous programming you can do using CompletableFuture, and also you can write code in functional way, what Future was not supporting. The CompletableFuture is an advanced version of the Future API, which basically gives you a lot of other API method to make the developer's job easy. Okay, and we're going to be talking about a little about the CompletableFuture today. As I said, you guys, right now I'm just introducing you to the asynchronous programming. I just want you to see and realize what asynchronous programming is, and I really don't want to bother, like, if you do have a vast knowledge on all this thing, I don't need it. You have to understand Future and CompletableFuture, I don't need it. But you know what, the Future and CompletableFuture, these things are provided by our Java core, our Java API, right? Our Java JDK, right? So we as a Java developer at least need to know a little bit, okay, what are they? We already have this Future and CompletableFuture available, using what we can do asynchronous programming. Then why we're going to go reactive, right? But before we go further, let me just give you a little bit of heads up on this asynchronous programming using Future and CompletableFuture, and let me tell you what it is. Okay. Maybe a long introduction, but we can just do some coding right now, and I think with that only we can be a little comfortable with this thing. Okay, so let me create another Java package. I'm going to be saying here CompletableFuture. Okay, it's very simple, guys. Say it once, you will understand everything. Okay. First of all, let me create a Java class maybe I'm gonna say future demo 1. I just want to recap future a little bit, just to make sure that we remember the things that we have coded in the last session. Imagine inside this future demo 1, we have few methods. Okay, imagine we have a method called public string, let's say get name. Okay, and it's returning a name. Let's say it's returning Selenium Express. But knowingly, I'm gonna do what? I'm gonna be adding a delay over here. Okay, I'm gonna say thread.sleep, and I'm gonna say 1000 or 2000 millisecond. Imagine, I will be getting the response from this method whenever I'll be calling this, but after 2000 millisecond, that means after 2 seconds. And I will be handling the exception right over here. I'll wrap it up with a try and catch. Okay. So you understand this, then I'll take you to our day-to-day programming, and I'll tell you why we're learning this. I'll just give you some real-time example of a real-time application so that you can understand better. Okay. But for now, we have a simple method, returns this, and it sleeps for this many millisecond. Maybe I can say get first name, and I'm going to say Selenium. Okay. I'll have one more method, Control C, and I'm going to say get last name, and I'm going to say express. Okay. So these are two methods, but the only thing is that the response I'll be getting after a delay of 2 seconds. Okay. Now, imagine I have a main method. I'm going to be dragging your attention to my main method. Now, if I want to call this method, let's say I have a requirement, I want to get the first name, I want to get the last name, and then I want to combine the result like Selenium Express I have to display. Then how can I do that? We can do like this. Okay, in our sequential programming, first of all, we need to create the object of this future demo 1. Future demo 1 is equal to new future demo 1, and future demo 1 dot get first name, and you're going to be getting the first name. Control Option V, you are going to be getting the string back, and then future demo 1 dot get last name, and again you're going to be getting a string back. Okay, last name, and then you want to do one thing. You want to add a first name plus last name, and this is going to get you a string back. Okay, and let's say complete name. Okay, understand this example. All this coming up example will be simple, and you're going to be saying s out complete name, or if it is a method, you can return the complete name by adding this up, right? And if I'm going to run this, it is go sequential, line by line. You can see this is keep on running, but after 4 seconds, I'm going to be getting the result Selenium Express. Okay, maybe if I want, I can just keep a double quote over here. But what I want you to notice here, the way our code flow is working, step by step, line by line, and obviously, and I'm getting the result after 4 seconds. Obviously, whenever I'm going to make this call, okay, this is a blocking call, right? This is a blocking call, obviously, because whenever I make this call, which thread is executing all this code, guys? By default, what thread is getting created?
Main thread.
Main thread. So main thread, first of all, starting this application, doing all this task step by step, line by line. So whenever the main thread makes this call, the main thread goes and wait for how many seconds? For 2 seconds, because of the delay over here. Okay, so we make the call and we are blocked. We don't know, whenever the response will come, we're going to be resuming from there. Okay, and then once we get the result, we make this call. Again, this is a blocking call, right? The main thread will go and wait whenever we make this call. Again, this get last name will process this for 2000 milliseconds, isn't it? And we're going to be getting the last name. And then once we're done with that, we're combining the result and printing it. Okay. But this is synchronous programming, right? So what is the time taken to do all this thing? you know how many second if I'm going to print it. But for your reference, I'm going to be printing it right now just to make sure that you're going to be getting the flavor of asynchronous programming with future and completable future, and we're going to be comparing it. Okay, now we basically going to do what? Let's say I'm going to say system dot current time in millis. So I'm going to say start time. Okay, and here I'm going to say maybe I just want to notice like how much time these two things are taking. Maybe I can put it over here. I can say this, okay, minus start time. Okay, imagine here I'm logging the time again and I'm finding the difference, and I will be wrapping it off with a bracket, and I'm going to be saying time taken to execute this task. Okay, and I'm going to say this. So if I'm going to run this, let's just see how much time it takes. Okay, and that this is expected, right? 4019 4 second, and then 19 more millisecond to do the rest of the things for this computation, all these things. But this couple of things takes 4 second, and this is the proof of that. Okay, now one thing we can notice with this problem is that this get first name and get last name, is these calls are independent, guys? The get first name and get last name, is these calls are independent or they are dependent? Only these two call. Can we go asynchronous over here? Can we execute this line parallel here? If we're going to execute this line parallelly, do you think our performance will be better? Do you think there is any relation with this call? And for this call, we need to wait for this call. To make this call, should we wait for the completion of this call? Is it required or not required? Think about it.
Not required.
Not required, right? Get first name is giving you the first name. Get last name is giving you the last name. So to make this call, why should we wait to make this call? Isn't it? So we are not dependent on the result of this call. Maybe after making this two call, we need to make sure that we are going to combine the results. So we need the output of this and output of this. Then only we can combine. So we can go asynchronous over here. We can execute this couple of lines in parallel. And how to do parallel programming? As of now, what do you understand? How can you go parallel? Yes? Yes. Last session. Last to last session, I told you guys. One API, I told you. In Java, yes.
You can implement callable.
Callable, correct. Why callable? Why not runnable? Runnable. So Vinik?
Because in callable we will be returning, we have return type.
We have return type, right? In runnable, we runnable returns void. But this method, if you're gonna be considering this method as a task, this method as a task, we need to capture the return type, right? So we're gonna tell a thread, hey thread, you go ahead and execute this method, but you execute it, and whenever that method executes, it's gonna return something. I want to get that return value. So if you're gonna capture the return value, if you're gonna give this work to a thread, and you want to ask that thread, okay, thread, tell me what that particular method returns, then you have to go for runnable, callable, not runnable, because the runnable returns void. So it's very simple. Here what I can do, I can go async. So let's just execute these two calls asynchronously. So what I will do, maybe this one, I will replace it. Okay. I will create a callable. Okay, callable. What the first method will return? A string. Whenever we'll call the method, it will gonna return me a string. And I'm gonna say hello callable. Okay. And I'm gonna be saying new callable. Okay. And I'm gonna override the method. Call method. Okay. You can write lambda as well if you'd like, but I just want to say this interface here is a anonymous way of extending or implementing this interface and overriding the overriding the method call, right? If you like to create a different class, you can create a different class, implement callable, override the method. Okay, that's also fine. I'm doing it in one place. It has the call method. Here, I will call whatever the method I wanted to call. That is like my future demo one dot get first name, and this is going to return me whatever. Okay, and I will copy this and I'll return this one. Okay, now here I have created a callable. Okay, and now what I'm going to do, I'm going to create another callable here for the world, or for the sorry, no sir, not this one is not hello callable. This is, I'm not printing hello world, I'm printing Selenium Express, right? So I'm going to say first name or something, first name. Okay, there you go. And then I'm going to have one more callable, right? Callable, this is going to have a string. This work also I want to do asynchronously. I'm going to say last name callable, and is equal to new callable of string, and then I'm gonna be doing this. Okay, wrap it up over here, override the call method, do an OK, and just execute your this thing. Okay, I'm gonna say get last name, and this is gonna get you the last name. And once this is gonna be done, I'm gonna be returning this. Okay, so I have two callables over here. Now I have created these two tasks. Now how to execute a callable? Can I create a thread directly, or how to create a thread, and how I can tell a thread that okay, you execute this task? How can I do that?
Use executor service.
Executor service, right? I will be using an executor service to create some threads. I won't be creating threads by myself. Rather, I'm going to be saying executor service is equal to executors dot fixed thread pool. Let's say I have two tasks here. First name callable, I will say callable, and last name callable. So I want these two tasks to be done. So maybe two threads I'll create. Okay, and I will have a method executor service submit, which takes a runnable or a callable, but the I will use the callable here. And here I'm gonna be giving the first task, let's say first name callable, and here I'm saying okay, I am giving this work to a thread. Okay, and like that I'll create another submit method, and I'm gonna say last name callable, and here you are going async. You're gonna be executing this and this callable in parallel. Okay, so obviously your performance will be faster once you make this. So now what will happen? First of all, your main method will start. Your main thread will start. Your main thread will do all these things over here. Okay, and then when it reaches here, you see, okay, he's making a call, but I'm gonna immediately return. I won't be blocking the call over here. This call I'm making, and I won't be waiting for this task to complete. I won't be blocking the main thread. The main thread basically gonna give this task to this thread, and then the main thread will not be blocked. From the main thread, another thread is taking responsibility to doing this task. Okay, and the main thread will be immediately returned and will basically go to over here. And here exactly you are basically giving another task to another thread. You are using the submit method. You are saying okay, this is a work of a different thread, this is a work of a different thread. Okay, and then let's say if you're going to handle the return type, I told you guys it is going to return a future. Okay, that means I'm gonna giving this responsibility to a thread, but whenever the work will be done, that result will be collected over here. I told you guys that before. Okay, so I can just write let's say hello future. Okay, not hello, it's say Selenium first name future, let me say. First name future. Okay, it's a future object that I'll get in future whenever this task completed by this thread. And then again, Control Option V, and I'm gonna say last name future. Okay, I'll go in parallel, right? And once I get the first name and last name, I'm executing these two things in parallel. But once this is done, then I have to do what? How can I collect the result from this future? I can just do future dot get. Now this is blocking in nature. This is the problem, right? Now you go parallel over here, and over here you go asynchronous. You're doing all these things together in parallel, but again you are waiting right now. Okay, once your things are done, get me the result. And now this is going to get you the string back. This is the actual string. This is the first name that you're going to be getting. Okay, and then same thing you can just do let's say last name future dot get. Okay, and here using the last name future, whenever the value will be available, I'm going to be getting the result over here. So I'm going to say last name future. Okay, and both these things are going to be throwing some. So now I'm going to be throwing the exception. Let's say I'm going to throwing it to the main method signature. Okay, and now once I get the first name and last name from this future, I'm going to be combining this and I'm going to be printing it, and I'm logging the time. Let's see the time difference right now if I'm going to log it. And previously it's text 4019. Now look at that. The time is significantly different right now. It's text 2017 millisecond. That means previously it was 4017. Now this proves that, see, here we have a delay of 2 seconds. Here we have a delay of 2 seconds. So 2 and 2, if you're going to do sequentially, it will be summed up. 4 milliseconds, you're going to be taking 4 milliseconds to complete that task. But here I have gone parallel. Okay, I am doing this couple of tasks in a particular moment, right? And then once their value are ready, I'm collecting the data over here. Okay, so here if I want to log the thing, let's say here I can also log it as out. Let's say this is inside first name, get first name. Okay, let's say get first name executed by thread, and let's say I'm gonna print the thread dot current thread dot get name. Okay, and same thing I want to print it inside the other last name callable. Okay, let's say get last name executed by the thread, and I'm printing the thread name. If I'm going to run this, you will see it has been executed by thread called thread1, and it is executed by thread called thread2, right? And I think this makes sure these two things are happening in parallel, and these things, the rest of the things, are done by the main thread, and you know about that. And if you want to prove that, then you copy this line, 1 second, and you put it over here. 1 second, I'm coming into your question. And maybe all these threads, whenever the main thread starts, okay, I think the main method executed by whom. So run this and look at that. It has been done by main. This has been done by thread 2. This has been done by thread 1. And this has been done by the main. Yeah. Question?
So why you are saying like get is a problem, like doing get in that main, because sometime we need to do get, right? To
Yes.
get the result.
I'm coming here in this example. Somewhere, sometime we need to do the get, and you have a point, Mahesh. Here we are doing a get. That means we are trying to get the value from the future. But why I'm saying it's bad, because still this is blocking, right? And like in this situation, it doesn't make more sense. But see how many times you are blocking. Okay, why you need to block for a couple of times? Is it fine? The get is a very costly thing. If you're going to do get, means you are blocking over there. What we are trying to achieve over here? Parallel. We want to go parallel. We want to go asynchronous as much as we can. Our code should be non-blocking. But here, this couple of lines, we're giving it to two different threads to do the things. But once we're back from here, again, this is blocking, right? So I will tell you like why I'm saying this is bad. And here you're doing get for a couple of times, okay? And once you get the data from this future, once you get the data from this future, then again you're combining the result. But is there any handy way of combining the result? Is there any handy API provided by future to combine the result? No, we don't have any handy API, right? And all these things can be avoidable if you're going to use completable future. And you can go async with completable future in a much easier way if you're going to compare to the future. But they do the same thing. The completable future and the future API does the same thing. They help you to go in parallel. They help you to go in asynchronous. Not I already told you in the last session that asynchronous doesn't always mean it's parallel, right? It all depends on your machine and the way your CPU and your processor works. But yeah, now what I want you to...
In completed future also we will do get, right?
In completable future also you will do get. And I'm going to be coming in. I'm just going to come into that. I'm going to come into that 1 second. But there, it will provide you handy way to deal with all these things. This example makes sense, right, Mohesh? And everyone, this example, what I have given you, whatever I have done you, whatever I'm trying to achieve, is that make sense? Anshuman, Arjuna?
Yes, Abhilash.
Yeah, okay. Arbaz, okay?
Yes.
Okay.
Yes, Abhilash.
Now let's just try to do the same thing, okay? Same thing in a different way. But before that, I'm going to be coming into the same example. But let's just come to the, another, let's say, completable future demo. See, guys, you don't have to understand future and completable future. You can do research in your own time, okay? I'm just telling you, this is how you have to go asynchronous in Java, right? So this is how you can make non-blocking call. So it doesn't mean that you have to understand completable future and future to go with the reactive programming. You can bypass this topic completely, but it's good to have knowledge about it, okay? Let me just tell you what completable future is. See, guys, imagine there is a method, okay? Can I copy one of the method? I want to write this code. Some code I have copied, huh? Let's say get name, I'm gonna say, and it's just giving me Selenium Express. Okay. Now there is a method called get name. It gives me Selenium Express. It takes 2000 milliseconds. It takes a delay of 2000 milliseconds. And let's say here in the main method, I want to invoke this get name method. Okay. But I want to invoke it asynchronously. Then how can I do that? It's very simple. In the future API, what you have done, you have created some executor service. I think just previously Sovanik was asking me to create this executor service, create some threads, and then giving each of the tasks that you have created using this callable by using the submit method. If you're going to use the submit method in the executor service, you are basically asking one thread to take the responsibility of doing this task. And like that, you have a pool of two threads, and to one thread, you are giving couple of tasks you are submitting, and they are basically executing and returning you the result, which might become later. It's like a placeholder in a box. Same thing will apply over here, but in a much better way. So basically, if you want to see here, okay, if I want to go asynchronous, it's very easy using completable future. You can use completable future dot supply async. There is a method, okay, and that's it. If you're going to use this method, you can supply any task to this, and supply async method takes what? It takes a supplier. And if you do remember, supply async method takes what? A supplier. And you remember the supply method from your Java functional programming, right? Supplier do what? It supplies you some data. It has a get method. It takes nothing, but always gives you some data, right? So the supply async method that you have in the completable future takes a supplier. So in case you are confused, just do new supplier and it's going to supply you what? Okay. Now I want to execute this. This is going to supply me a string. Okay. So I'm going to say supplier of string and going to override the method over here, get. Okay. And now what I'm going to do inside this get method, I can call that method called get name. Okay. So I'm going to create the object of this. Let's say completable future demo, completable future demo is equal to new completable future demo, or you can use var to create this in the latest Java way. But yeah, I'm sticking into the traditional approach of creating object, and I can say dot get name. Okay. And that's it. You are executing this task in asynchronously, right? The main thread will start over here. It will create the object. Now here the main thread basically submit the task. It's basically going asynchronous and submitting this task to the supply async method, right? And then let's say I'm going to say s out. Let's say done. Okay. Now let's just see what is going to happen if I'm going to run this. If I'm going to run this, let's say run future demo 1, stop and return. Okay. Right click, run. It's running the previous program. See, now it is giving me done immediately. But I'm not saying whether this thing is executing or not, right? So basically, the supply async. So here, what is I'm getting done over here. So what you are assuming? What is happening? The main thread is starting over here. Okay, it creates the object. Then the main thread is submitting a task to this particular method. Okay, the main thread is basically giving a task to the supply async method. Okay, you do this work. The supply async method will do this work in a different thread, but the getName method basically takes 2 milliseconds to return a result, right? But the main thread is going to give the task to this guy, and it doesn't have to wait for 2000 milliseconds to getName method to return something. The main thread will immediately get the response from the supply async method that, okay, main thread, your task is done. You have given me the work. I'll be doing your work. You are free right now. Then the main thread is released. Then the main thread is printing done over here. And by the time it's printing done, okay, it's just saying, okay, program completes, right? So it's basically not waiting for this thread to print the result over here. Okay. So basically what we can see, if I want to see the result after the supply async method, it has a handy function. Okay. It also, you can also do this thing, Control Option V here, Control Option V to handle the return type. See, it is returning you the completable future. Just like the future, you can get a completable future, and you can just do completable future dot join to block the thread. If you can do join, that means your thread will be blocked over here. If you can do Control Option V, you can get the string back from this completable future. This completable future is returning a string back because the supplier method, the work that you are giving to the supplier method, this is gonna return you a string back. The get name will gonna return you the string back, and I'm gonna getting the string over here, right? But if you're gonna do this, and if you're gonna do like this, this is how you code in Future API, right? If you're gonna print this, let's say value, okay, and value over here, then you're gonna get the value. But what you are achieving over here? Nothing. You are going asynchronous over here, and then see, first it is printing Selenium Express, then it is printing done. Okay, that means here you are doing join. Okay, that means you are asking for the value to this. Okay, you can also do get, just like your future. You can just do get, and you can just handle that unhandled exception. But whenever you do get or join, you are basically blocking the main thread. And you are giving this task, and you're saying, okay, I want the value right now. I want to do join. I want that particular future value right now, that completable future value right now. Okay. And whenever I get the value, I'm printing the value. And after that, I'm going to the next step, right? So I'm not going asynchronous. I don't want to do this. what I want to do, what future API, the way the completable future API is better than future in this way. See, you are supplying a task, right? You are supplying a task here to the completable future, and you can write this thing asynchronously. You can convert it to functional programming, right? You can just remove all this thing like this, okay? And you can remove all these things like this, and you can give a lambda symbol like this, and there you go, right? You can take all this thing to one line. You can take all these things to one line like this, and you can also remove the return, right? If it is one line of code, and look how clean is your code is. And this is it to start a completable future. This is it to initialize a asynchronous programming in Java using completable future. And this is it. If you're going to write this lambda expression, that means you are saying supply async method. I'm supplying you with this task. I'm using a supplier which doesn't take any arguments, but I'm telling the supplier to execute this task and return me the value, right? Return me whatever this value will return. Now, whenever the value will return, I can also do some chaining kind of thing. Just like you are chaining in your stream API, in the same way you can chain over here as well. Okay, so how can we chain the data? See, what I'm saying, okay, hey thread, you do this work. And whenever you get the result from this work, do this, okay? Whenever this thing is done, what I want to do, I want to do dot, and I'm going to say then accept, okay? And there is a method called then accept, which is going to take a consumer. You can see then accept, there is a method which takes a consumer, okay? That means this is going to consume the value, whatever the output of this, that will be the input of this then accept. Whatever this is going to return, this getName method is going to return you something, right? It's going to return you a string. I'm going to capture that string. Okay, I'm going to capture the string, and it's a consumer, and I can just print it just like you are using a consumer. Same way I can just say str over here. Don't you think this is cool? Now what I'm saying, I'm supplying a task. I'm supplying a task to this supply async method, okay? And whenever this task execution is done, whatever the output it is going to return me, that output is going to be the input of this then accept method. Once the execution of this thing is done, then I'm going to be capturing the data and printing it over here, okay? And let's see whether that happens. I'm going to run this, okay? Now it's saying done, because the getName method is giving me the result after 2000 milliseconds. And by the time the main thread is giving the work to this, okay? And then the main thread is immediately released because this is asynchronous programming. This will be done in a different thread, and the main thread is printing this and then saying I'm done. Then this thread is basically returning the result after 2000 milliseconds, and by the time the main thread is done and already terminating the program. So let me hold for a minute. You can just do join again, or I can just do this. I can just do thread.sleep, and let's say I'm going to sleep for, let's say 3000 milliseconds or something, okay? Or maybe I'm going to be activate this thread, the main thread, for 5000 milliseconds. I do not want the main thread to terminate, okay? Now if I'm going to run this, you see, first the main thread is printing done. Then after 2000 milliseconds, it is saying Selenium Express. Once this task is done, I'm printing this, and then the program is terminated after 5000 milliseconds. I'm holding the main thread a little bit over here, okay? Now you see, how good is this? You are not creating a thread pool, execute a service by yourself. This completable future behind the scene using a thread pool and supply whatever task I'm giving to the supply async method. This task has given to one of the thread which has been created by the completable future behind the scene. And once this task is done by the thread, I'm also telling that thread, hey thread, you don't need to return to the main thread. You need to do what? After you complete doing this thing, you perform this task, okay? First do this thing asynchronously by creating a new thread, and then once you get the result, then you apply this thing, and here you're saying then accept that particular thing that this particular method is returned, and then just simply print it to the console. That's what I'm saying. And if you want to see like by which thread this guy is executed, again I can print that thing over here. Okay, 1 second guys. Do we need to hold the main thread always? Yes, that's the problem. Now in this case we have to hold the main thread, but we don't need to hold the main thread, right Mahesh? We anyhow we are blocking, right? If you're holding the main thread, then we are blocking over here, but that's okay.
Yeah, it's not a good way, right?
It's not the good way, right? Exactly. That's what we are still blocking. But still, don't you think this is the improvement if we're going to compare it to the future API? Now I'm going to give you some more example. Hold on for a minute. See, now here I'm going to say, let's say this is my getName method, which is going to return Selenium Express. I'm going to print s out, and I'm going to say executed. Let's say getName method executed by which thread. You see, you can understand. getName executed by which thread? Thread dot current thread dot getName. Okay. Now also I'm going to do the same thing. I'm going to put it inside the main. Okay. And I'm going to say main method executed by which thread. Now if I'm going to run this, I told you, right? Here a new thread will be created, right? So you're going to be seeing that. See, main thread has been executed by main, but the getName method has executed by whom? A common pool worker one thread. There is a worker one thread. I told you this completable future behind the scene does what? Is creates a pool of thread. If you're going to remember, if you have watched my parallel stream video, I have told you about the fork and join framework. The fork and join framework basically is the uses behind the scene. The completable future behind the scene uses the fork and join framework. And the fork and join framework basically helps you to go parallel, right? So basically the completable future is basically using a thread pool behind the scene. And that thread pool has been created by this fork join pool. There is a fork join pool where basically a lot of threads are there. The completable future is basically borrowing one of the thread and giving this work to that thread. So you are not creating the thread. The thread has been created by this guy behind the scene. Isn't it cool? You are not creating executor service, and you are not creating a thread pool. You are not defining how many threads will be created. And all these things are done in just one line. And also, you are not only giving the thread to do this work, you are also giving the thread a responsibility. After that work is done, whatever that returns, make sure you are printing it by using the then accept method. Okay. Now let's just do one more thing. Okay. Now let's just go to our previous project, future demo. This is the code that we have done previously. Now see, you have previously what we have done. We have two methods, get first name, get last name. First name returns Selenium, last name returns Express. And the first name basically holding it for 2000 millisecond. The last name is holding it for 2000 millisecond, right? Now, let's say I have a task. I have to make sure this task and this task will go in parallel. They'll go asynchronous, okay? So I don't want to use future API. I have done all this blah, blah, blah work, you see, to make things done. Okay, now what I can do, I can basically remove everything. Okay, maybe till here I can remove everything, and see here I'm not doing anything. I'm just saying the main method is started by this thread, and here I'm just starting my time, and I'm logging my time over here, my start time and end time. And here is my future demo object, because I want to call this methods called get first name and get last name, right? Now let's just do the same example using the completable future. How to go async? By using the supply async method. I can just do completable future, the supply async, and I'm going to provide it a task. And to provide a task, I'm going to be passing in a supplier. The supplier takes no input, but it's going to return you something. And I want this supply async method, I want to do this operation asynchronously. Which operation? I want to basically call the get first name method. Okay. And this work, I want to go asynchronous. Okay. And similarly, I want to do one more task. Then I want to say completable future, then supply async. I also want to go async whenever I'll be calling this method. And I'm going to say future demo1 dot get last name. Now look at that, right? I am going asynchronous with just these two calls. And don't you think it is fancy and it is much more improved than the future API, the way we are doing the completable future things over here? Obviously, it is. Now, what is our expectation? The expectation is this work will done and this work will be done together at a time. The main thread basically will be immediately returned whenever it is going to execute this line. The main thread will not be blocked. The main thread is giving the responsibility to do this particular operation to a thread created by the completable future behind the scene. Okay. And similarly, the main thread will not be blocked whenever it will be executing this line. It is giving the work to be done to a different thread. And then the main thread will be printing this. Okay. Now, what I want, so this thing you forget, this is something different. Now what I want, whatever this returns, what this will supply async method will return what? It will return a completable future. Okay. Let's say I'm going to say completable future. And I'm going to say, let's say this is first name. Okay. And this is also going to return you a completable future. Just like your future API, this will also return you a completable future. And let's say last name. Okay. Now these two things will go in parallel, go asynchronous. And now what I want to do, whenever the result is complete for completable future first name, same thing you can do. You can do completable future first name dot join or get. You can just do this. You can get the value from that particular future, and this will be your first name. And like that, you can again do completable future last name dot get, and again you can just do the last name you can get, and you can combine the result by doing first name and last name. But I don't want to do that. I want to show you a cool thing given by the completable future. Here, this is a future. Okay. It is doing some work. Okay. I want to combine this future and this future. I want to combine the result of this. You can do that easily with completable future. See, this is a object of what? Completable future, right? I can do completable future first name dot combine. Okay. Then combine. Okay. And then I want to combine this future with this future. Okay. Then combine method I'm using. And the then combine method basically takes two arguments. First, it is taking the completion stage. Completion stage means you consider that as another completable future. This is the super interface of completable future, I think. So it takes another completable future, and then it takes a by function. And you know by function what it takes, right? It takes two input and gives you an output. The apply method takes two input and gives you an output, right? That's what we need. If you're going to go to the future demo, I'm saying this future, then combine with this future, and whatever result this future is going to give. What result this future will be giving? A string, right? So I'm going to take the future one result and the future two result. Okay. The future one result will be the string. The future two result will be the string, right? We're combining this future with this future. This future will return a string. Maybe I can say str1. This future will return a string. I'm going to say str2. Okay. And then I can do what? I can just do concatenate, right? Or I can just do this str1 plus give a brace here, then str2, right? This is what I want to do, right? Now this then combine method, this is a handy feature. I want to combine this future and this future together, and after the combination happen, I want to perform this task, right? I am completely going, here I'm completely doing functional programming, right? And if I can do control option V, this is going to return me another completable future. But I do not want the completable future. I just want, one second, don't put anything on the chart. 1 second, let me complete. Once we do all this thing, I do not want a completable future. I want to use join. I want to get the result. Okay. I want to block the thread over here. Okay. Make sure this is complete. Make sure this is complete. Grab the value from this future. Grab the value from this future and put it over here. I'm taking that couple of value from this couple of future, okay, whatever the output of that thing, then I'm summing it off, and then I'm waiting for that couple of value to arrive, and that's why I'm using join. Now this join will give me a value, which will be a string. This will be my final output, okay, final string. And obviously you know what will be the value that I'll get over here. Okay, I'm gonna say final output over here, and you know what I'll be getting. I'll be getting Selenium Express, right? Which one I have to run? This one. Now look at this. Main thread executed by main. See, this one has been executed by main thread. Then I'm getting Selenium Express, and the total time takes how much millisecond? 2 seconds. 2020, and obviously that's fair, because here I'm going asynchronously, and then I'm joining, and I'm doing some other things as well. I'm printing and I'm doing some other things, so it takes a little bit of more time. But here, if you're gonna expand, if you're gonna make it 4000 millisecond, and this has to wait for, let's say, 3000 millisecond, right? Get first name and get last name. So if I'm gonna sequentially make call, then 4000 plus 3000, 7000 millisecond at least it is going to take. But now let's just run this. Or maybe if I'm going to say 4000, then 8000 millisecond at least these two methods will take. Now let me go asynchronous and see how quickly the things can be done. Okay. I think it will be done in 4 seconds. See, the 8-second work, you're doing it in 4 seconds. Okay. But now few improvement we have done. We have a handy method called then combine, which is helping us to combine the result over here. Okay. Combining couple of completable future over here, and it is helping us to summing it up. And then we have a handy method called and basically we are making a join call, which is basically blocking the thread. But how many times we are blocking the thread over here? We are not blocking the thread for 2 times to get the result from here, we are just blocking the thread for only 1 time over here using this join. Okay. Ashok, what if the first method slips for 4 seconds, the second method slips for 2 seconds? Doesn't matter, right? It will be done that faster, right? You will be seeing if you're gonna be executing these things sequentially, it will take 4000 milliseconds, it will take 2000 milliseconds, it will take 6000 milliseconds. But in this case, it won't be 6000 milliseconds. Okay, you'll see it will be executed faster. Okay. It takes 4000 milliseconds. Okay. So that's the beauty. That's the beauty of this. And we are just blocking the thread for 1 time over here. You are not doing future.get for 2 times to get the result from this couple of future. Rather, you are just doing 1 block and that's it. You are getting the result. Right. And
Abhilash, like here we are blocking 2 threads, right? Like join in the sense, like since we are combining both, right?
Correct.
Yes, like we are blocking, but not at that same place, but somewhere we are blocking.
Somewhere we are blocking, exactly. So basically, the thing is, if you're gonna do this, Swati, completable future first time dot get, you are blocking, right? You're gonna say, okay, whenever the value arrives over here, whenever this method basically returns me a value, maybe after 5 seconds or 10 seconds or whatever, I want to get the value. But wait till that, Control Option V. Okay. And I'm going to say, and then completable future last name. Again, I'm going to say completable future last name dot get a join. If I'm going to do over here, then again, I'm going to say, okay, just block it. Okay. And grab the value over here. Now you are blocking here and here. Now, what if whatever, like the last question was, here I am taking 4000 millisecond, here I am taking 2000 millisecond. Don't you think by the time you're gonna, here you will be blocked, right? You will be blocked for how many millisecond, Swati? If you're gonna be executing this call? 4000 millisecond, right? Yes. But these two things are happening asynchronously, right? Happening together. So here if you are blocking, don't you think you're going to be getting the result from this completable future last name even faster than this call? Yes, right? So what is the point of blocking over here, right? Why we're blocking over here? Here we'll get the result faster even. Here we'll get the result in 2000 millisecond, right? So why we're blocking over here? Here, just because we haven't got the output of this thread, whoever doing this task, right? There is no point of blocking for that thread. Even we're getting, if you're already getting, already this completable future work is done, right? By this time particular completes. So there is no point of blocking this particular guy, right?
Yes.
So
Yeah.
even though like instead of blocking for 2 times here, I'm just blocking 1 time here. Okay, so make sure I want to combine these two. I want to get this value and this value and I want to combine. And if I don't want to do join, then again it is going to return me a completable future. It is not going to return me a string. It's going to return me a completable future. It's going to say, okay, I'm going to be joining you and will get you the value, right? It's going to return you a completable future. This value will come in future. But now here I want to say, okay, I don't want to, this is just the result that I want. So join. Okay, I want to just get the value. Just get me the value. Or you can just do get. Okay. Now this is going to get me the final output, right? But this is in string format. This is not in completable future format, isn't it? Okay. So this then combine method is helping you to combine couple of futures together. And that's a good thing, right? And you are just blocking for 1 time. And this is going to help you to understand a really cool thing. We don't have much time, but guys, can I take 20 minutes more, because I will not be able to join tomorrow and maybe for next 7-8 days. So is it fine, or do you need to go office? Guys, can I go 10-20 minutes more?
It's fine.
Yes.
Prajakta, too late for you? Venu?
No, I'm in India only.
Oh, you're in India. Okay. Venu, office, Vamsi, you guys are okay? Sunil? Spriti, too late for you? Saga, all okay, right? We can go, right? 20 minutes more. Okay.
Yeah.
Yes,
Okay.
Abhilash.
Okay, Alok. Okay. So this is what, just understand, guys. Just understand one thing, asynchronously we are doing the things, okay? And blah, blah, blah things. You just go and do your own research and understand. I'm not drawing diagram knowingly, because if I'm going to draw it, even I will also go, I will also get into this thing. And again, I'll take a lot of time, and I don't want that thing, because my main intention is to go reactive, right? But this is also asynchronous programming. We're doing asynchronous thing. I also want to show you one more thing, guys. See, this is one of the example that we have done before. What we are doing over here, we are doing completable future or supply async, and look at this line. Here we are calling one method called getName. Okay, the getName method will be called. Okay, that will be done by a different thread. Okay, and basically it is going to return us the result after 2000 milliseconds. The result will be Selenium Express. Cool. So that is something that it is doing, and we're doing then accept. Once we get the result by that thread, we're also telling that thread to do this thing, like printing this thing to the console. Also, guys, you can do a whole variety of work. Just like this, you can just do a dot, okay? And you can say, then apply. There is a method. Okay, you can apply some other thing over here. For an example, you see, I'm basically doing this work, and then whatever this is going to return, what this is going to return, the getName method is going to return what? A string, right? Now I can take that string and I can say string dot to uppercase, something like this. Okay, now you see the beauty. If I'm going to run this, which one I'm running? I have to run this program. This is just like your stream API, isn't it? We're just chaining the methods over here. Okay, and look at that. You are getting the Selenium Express in all capital letter, right? So whatever output this gives, that will be the input for this. Okay, this supply async method, using this we are initiating our asynchronous programming. And then to that thread we're saying, okay, once you do this, then apply this thing. Okay, then apply, then do this work. Once you get this result, then you do this work. Okay, and then this is just like a completion kind of thing. This is just like a completion method. Then accept. Then you accept the method and you print it over here. Then you accept the output whatever this gives. The then apply method basically takes a function. Function, it takes an input, gives you an output, right? It takes an input, gives you an output. This two uppercase will be the output. Now, this is just like, you can treat this like as a terminal operation. You are capturing that output and you are printing it over here. And end of the day, you are forming a kind of pipeline and you are telling one thread to do all this thing. Okay, isn't that cool? And all this feature you're going to be getting if you are using completable future. With future API, you won't be getting this all these benefits of chaining the methods, doing functional programming, something like this. That won't be possible. That all happened after 1.8 version. This is if somebody is asking you, tell me one feature of 1.8 version, you can tell them about completable future. Okay, this is one of the most ignored thing, but this is a beautiful thing already given by Java if you're planning to do asynchronous programming. Okay, so if it is there, if the completable future is there to perform asynchronous programming, then why we're learning this reactive, right? I'm going to show you an example. Okay, and for that, just give me a minute. Just give me 1 minute, guys. I think I have coded an example yesterday just to show you, and they can relate to that thing. And this is something that you can more relate to. Okay, 1 second. Just give me 1 minute. Okay, I will close this. Okay. I want to give you a code walkthrough. Very simple code. All of you can understand. Just see what I'm trying to do, huh? So, this is my idea. 1 second. Okay, guys. So, see this. Imagine you have a product. Okay, there is a product service, okay, which will connect to a kind of database and help you to retrieve all the products. Okay, just like that, you have a review service, okay, which will connect to its own database and will help you to grab all the reviews written for the product. Imagine here in this database, you are storing a lot of products, like in your Amazon, okay, you are purchasing different products, right? Imagine there is a DB where you are storing all the products. Like that, there is a DB where you are storing all your reviews for the product, for a specific product. 1 second, don't put anything on the chat. I won't be able to reading it for the last time. Oh, I am not able to scroll it. Sham, I'm dropping. Okay, Sham, no problem. It's a very simple thing. I'll send you this diagram and pictures and you can understand all these things, Sam. No problem. Good day. And then imagine this is product, this is review. This is where we're storing review. Then imagine if a end user is asking us for some product, then we have to show him product as well as the review for that particular product, isn't it? As one thing. And if you have gone through the microservices architecture, you are already familiar with this kind of thing. We have different services which is connected to different DB where we're storing different result. But at the end of the day, whenever the client is asking for, hey, show me the laptop, show me the, let's say, MacBook Pro M1 laptop or M2 laptop or M3 laptop, then you have to show the user the specific product, isn't it? So how can you do that? You have to write, imagine one more service. Imagine this is your product info service. The product info service will make a call to this, and it can make a call to this, and can grab the product, grab the review, combine the product and the review together, and return the output to whoever is calling to see the product. But the thing is, the product data is here. The review data is here. There might be another service which is making a call to this service and combining the result and giving us the result back, isn't it? That is mostly how we write code in a day-to-day programming. Okay, even though you are not acquainted with your microservices architecture, you already doing this kind of thing in your day-to-day project, right? You are making some DB call, getting the result, then making another DB call, getting the result, then making some another call, getting the result, then finally doing something and returning another result, right? Or returning a final result. But the problem that we do in our day-to-day coding, once we make this product, let's say somebody is asking for some laptop. Okay, now this product, imagine there is a product info service. The responsibility of the product info service to make a call to the product service and the review service and grabbing the product and review together that the user is interested for, combining the result and returning the result to the user about that product and the review information in a single source of information, right? But the way our traditional code works, we make a call to the product service, then we make sure it processes the data, returns us the result, and then we make a call to the review service, we make sure it processes the data, then return us the result. Then maybe if it is going to take 8 seconds to return the result, it takes another 8 seconds to return the result. Then the complete time that we spend to wait to complete this couple of tasks is 16 seconds. But imagine if these two services are not related. This is some different call, this is some different call. Product service has its own database where we store product. Review service has its own database where we store review. Then we can make this call parallelly, asynchronously. We can do these things together, isn't it? So why to wait for 16 seconds? We can make this call together and we can get it done in 8 seconds, right? And that is something that we're going to be seeing right now. Okay, I have created a kind of replica for you guys. Just see whether you can understand this, and you don't have to crash your head or how the things has been done, what I have written. This is just to save some of the time. You don't have to replicate this program. Just understand what I'm trying to achieve. Okay, you can do this kind of programming by your own. Think accordingly and you write the code. But my main intention that I am trying to explain you over here is this. Imagine there is a shopping cart application. There is a product. There is a class called product. Okay, you don't need to see all these things. Just see the product thing has this thing: product ID, product name, category, and product description. Product ID will be, every product will be having an ID like 101, 102 or something. Product name means laptop, mobile, TV, whatever. Category, imagine if the product name is MacBook, then the category will be laptop. If the product name is Sony, let's say Sony Galaxy TV, then the category will be TV, right? Then the product description will be the description about that particular product. And there are some constructor, getter, setter, and the toString method for the same, right? There is a domain class or a model class called product. Now you think there is a class, there is a service class called product service. You don't have to worry. You don't see the code. I'll tell you what this product service is doing. This product service is having a method. If you're going to call that method and tell that method that, okay, I want the details about product 1, then it is going to give you the details about product 1. If you're going to ask the product service that, okay, I want to get the details of product 2, then it is going to get you the details about the product 2. Okay, like the description, the category, the ID and everything. Okay, maybe imagine you are making a database call to fetch all the product service detail. But this is how I have hard coded the thing. You don't have to worry about this thing. It's just simply I have created a method. I'm accepting an ID. Okay, I have 3 products created. Let's say MacBook, Dell, and Lenovo. And let's say MacBook has this information, MacBook Pro, it is a laptop, 16 GB of RAM, Retina display with Intel i5 CPU. Like that, another product I have created, Dell. Okay, ID2, Dell Inspire is a laptop, and this is the description. Like that, I have product 3. It's a Lenovo ThinkPad laptop. It's a laptop. It's a 8 GB of USD display with Intel i3 CPU. Imagine there are 3 products. And imagine if you're giving me ID 1, I'm returning MacBook. Okay, I have created a product variable called RET and setting. If the ID is 1, I have a switch case. If the ID is 1, I'm returning MacBook. If the ID is 2, I'm returning Dell. If the ID is 3, I'm returning Lenovo. So I have hard coded the thing. If the ID is something else, let's say 10 or 15, I'm just returning a simple product. without having all this information. Okay. And one important thing that you have to notice, this get product by ID method, if you're going to call that, okay, I want to get the details of product 1, it will give you the product details after waiting for 3000 millisecond. Okay, that is the important thing. Okay, imagine it is a DB call. You don't have all this thing. You are making some DB call. Okay, the DB call is returning you the product. Let's say you are asking for the ID 1, then that DB call is returning you the ID after processing the data for 3000 millisecond. Okay, that is the only thing that you have to hour. Okay, this is my product service which is giving me the product. Okay, based on the ID, it is just returning me that product. If I'm going to ask ID 1, it is going to return me MacBook Pro. Okay, that's it. Okay, I don't think you need to be confused with this. So that's it. This is my product service. Like that, I have a review. Okay, review model or a domain class. Okay, the review does what? It has the product ID and the rating. Let's say product ID is 1, then the rating is 4.5. Product ID is 2, the rating is 3.2, something like that. I'm going to be storing my review like that, my review objects like that. And I have a constructor, I have a default constructor, I have a toString method. Nothing fancy, simple. And then I have a review service. Okay, the review service does what? It's going to help you to grab the review. Imagine you have a method. Don't see the code. Imagine you have a method where you are saying, okay, review service, grab me the review for product ID 1. Then the review service is hitting the review service database and doing some processing and grabbing you the review for product 1. You are asking, hey, review service, grab me the details for or review for product 2. Then it is again doing processing, grabbing you the result for product 2. That is something that I have done over here. Get review by ID. Here you have to pass the product ID, right? I have created some fake review over here, product 1 review, product 2 review. Just initialize the object and returning the object based on some switch cases. If the ID is 1, it is going to return this object. If the ID is 2, it is going to return this object or this or the other object. This is something that I have done. If the IDs does not match within 1, 2, 3, then it is going to return a fake review, like a random review without initializing the data. Okay. But the important thing is that it sleeps for 3000 millisecond. That means whenever you're going to ask for the review, imagine if you have a slower database, then it is going to process the review, or imagine the database is taking 3 seconds to process the call and returning you the review details, right? So you have a product service, which is basically helping you to return the product. Okay. And then you have a review service, which is helping you to return a review for a given product. Okay. These two things are making sense, guys? Yes, no, understanding? Guys?
Yes, sir.
Nothing fancy, right? Simple.
Yes.
So I don't want to write this code in front of you. So just hard coded. My main intention is to show you something, just to give you an idea. Why do you need the reactive programming? What is the need? Why you are learning all this fancy stuff? Okay. Now you see a review service and product service. Imagine there is a one more service called product info service. The product info, imagine there is another model which is taking the product and review. It has two dependency, product and review, and it has a constructor to construct the complete product info. The product info object consists of the product as well as the review. Imagine this is one final object that you need to return to the user. When the user asks, okay, I want the product info, then you are saying, okay, you want the product info about, let's say, the laptop, MacBook laptop. Then imagine you want to make a call, grab the MacBook laptop product, grab the MacBook laptop review. You have to combine them. So you have this constructor. Okay. So to do that, I have a product info service. Okay. And that is something we have to write. Okay. Imagine you have a product info service here. The product info service has a method called get product details. Somebody need to tell, okay, I want to get the details of number 1 product or number 2 product or number 3 product. Then we have to grab the details and give the product info object. And the product info object is consist of product and review together. So you can see in the return what I'm doing, I'm returning a product info. Here it is null and null. So I have to make sure I have to grab the product details. Okay, product, let's say product, and this details I have to grab, and I have to grab the review details. Okay, review. Okay, review is equal to null, and then this product I'll feed it to here, the review I'll feed it to here. This is something that I want to do. Okay, now I think you are starting to realize or understand why we do reactive programming over here. Are you getting a kind of sense that what we are trying to do over here, guys?
Yes, Abrash, yes.
Yes, right? Because I told you, here we're gonna make a call to feed the product, to get the product. Here we're gonna make a call to get the review. But doesn't mean that we need to make sure, let's say here we need to make sure to get a DB call. And here we will be doing a REST call, for an example, or blah, blah, blah call. Let's say this call is taking 10 seconds to process the data and get us the product. Then why should we wait till that execution to complete in order to do this thing? Because there is no sense of waiting to make a call for to get the review. If you're making a call over here, then why should we wait to the product call to get complete? Okay, we can go parallel, we can go asynchronous, right? And we can reuse all our threads and resources, which is basically come into the picture when we are talking about any web application. Okay, now let me tell you how. Imagine here I am creating product service, okay, and I'm gonna say product service dot get product by ID. Let's say I'm gonna say whatever ID, 1 or 2 or something. If somebody is going to make this, call this method, and I'm gonna pass 1 over here, I'm gonna be giving 1 over here, get the product over here. Imagine this is a blocking call, right? It is gonna block my thread for 3000 milliseconds. If you're gonna remember, this get product ID will get me the product, get me this RET. RET is a product, okay? And this RET I'm setting over here, MacBook or Dell or something. But the main important thing is that it's not going to return me the result immediately. It's gonna block the thread, okay, for 3000 milliseconds. Like that, let's say I have a review service, okay, and I'm gonna say review service dot get review by ID, okay, and I'm gonna say I'm gonna pass in the ID, whatever the ID will come over here, and I'm gonna grab the review. And again, this is a blocking call, right? It's also going to block my thread for 3000 milliseconds, okay? So if you're gonna go sequential, if you're gonna call this method, okay, after Java, and let me do one thing, guys. Here, let me initialize all this thing. Let me not do auto wearing or any kind of drama here. Simple thing. I'm just initializing this review service and product service. You do understand that, but if you're gonna use Spring or anything else, then this service need to be auto-wed, right? But you do understand that, I believe. And now this product info service I'll be using in my app here. Let's say product info service is equal to new product info service, then info service dot what is that? Get product details. And let's say I want the details for ID 1, okay? And let's say I'm gonna grab what is that? Control 1 to grab the data, okay? Product details. And I'm gonna say, let's say product info details, I'm gonna say, okay? And I'm gonna print this result as out, okay? Product info details, okay? I'm gonna log the time as well, current time in millis. And let's say I'm gonna assign this to long start time, okay? And look at that. I'm gonna copy this, put it over here, and let's say this is the end time, okay? And then I'm gonna say s out total time taken. I'm gonna do start end time minus start time, okay? Just want to show you how this thing works together. I'm gonna run this, okay? Look at the result. Where is my output? Yeah, look at that. Sorry, 1 second. I'm not able to see it properly. Yeah, you can see it over here. That's fine. You can see the product info. You can see the product info is 1 MacBook Pro laptop, and the review for ID 1, the review is 4.5. The total time taken is 6056 millisecond, right? Because we are doing sequential programming. Whenever we are making this call, we are making this call, which is blocking. We're making this call, which is blocking. Then we are combining the result, right? But we can go async as well, right? I told you how to go async. How to go async? We can go async by doing the completable future thing. If you're going to use Java, okay? Then how can you do that? You can just do completable future, okay, dot supply async, and you can take a supplier and you can return whatever this guy returns, right? You can give this task over here, Control X, put it over here. There you go. You're going to say, okay, do this thing, but you have to do it asynchronously in a different thread, okay? Now, this is not blocking. This is non-blocking right now, right? Non-blocking. You don't have to wait. This is going to immediately return you the data. Just like that, you have to make another call, completable future dot supply async, right? And you're gonna say this one is review service dot get review by ID, and I'm gonna pass in the ID over here, okay? And there you go. Now these two things gonna get you, this is gonna get you a future. 1 second, cancel. Control 1, assign statement is gonna get you the future. This is the product future, and this is the review future, right? Control up this intelligent Eclipse I'm using together, right? So the shortcut I'm not able to hit properly. Let's say this is review future, okay? But now these are two non-blocking call. These are not blocking call. I'm just creating two different threads, and then I'm gonna say what I want to return a product info, right? I want to return a product info. So let's say I'm gonna say product info is let's say is equal to null, and this product info I want to return. Now what I will do, now this is what I want to return, right? Let me remove this. Now I want to return product info, okay? Now how do I get the product info? The product info object I have to construct, right? But I have to construct by taking the value from this future. Whenever this particular call goes, I will be getting the product future, then the review future, and from this future, I will get the review. From this future, I'll get the product. I have to combine that. And how can I combine? I have to already told you product future dot then combine, okay? Then review future with what I'll be combined. Then this future will get me what? Product. So the first parameter value that I'll get over here in this by function is going to be product. Second value, this review future will give me what? Review. In the second value, I'll get review. If you're gonna do get over this, you're gonna get review, right? Then with this, what I'm gonna do, I'm gonna construct a object, right? I'm gonna say new product info, okay? And I'm gonna pass in the product that I'll get from the first future, then the review that I'll get from the second future, and there you go. And this is gonna get me a completable future. But I want to get what? I want to get whatever this returns. This returns what? Now this by function takes this couple of things and return you this object, right? So if you're gonna do dot join, you're gonna get what? You're gonna get the product info, whatever object you are returning, right? Again, I'm hitting Control Option V. It should be Control 1. Assign statement to a new local variable. This will be product info. So I can directly assign this to the product info here, and I can return this, right? There you go. You are making asynchronous call right now, and look at that, right? But end of the day, you are achieving asynchronous way of calling things. Right now, if you're going to run this, things will be drastically better, right? Previously it takes, now it takes 3051 millisecond. Okay, it's better, right? Better than the before. The last one, if I remember, it was 6000 millisecond. Now see, it is right now 3042 millisecond, and these calls are not blocking. But there is a problem. You can now the whole point of all these things, all this explanation is this. Now see what you're trying to achieve. End of the day, asynchronous programming, right? But what you are achieving over here, cool, you are achieving the asynchronous way of calling things in a non-blocking way over here. But end of the day, as I think Mohesh was asking previously, we are still blocking. We're still doing join. Okay, imagine if it is a controller. Okay, imagine it's not a service, it's a controller. Then in your Spring, how do you write controller? You write things like this, right? Get mapping, something like this, and you have some things like this. Let's say product. Let's say product slash, let's say product ID. Let's say ID. Okay, and that ID you'll put over here. And end of the day, you want to get the product info. Now imagine why you are trying to do all this drama here. Okay, why you are doing all this drama here? Because end of the day, what we need is whenever somebody is making a request to our server, that request will come to our server. Now that request will be taken by one thread, right? Thread per request model. If that request will be handled by one thread, and that thread, let's say that thread is handling this, and then you are basically spanning off your threads. You are basically creating two threads, and then you are processing the things parallelly, and then end of the day, you are still blocking the thread over here. Okay, then how you will say that you are efficiently using the thread? Okay, the thread per request model, if I told you we have limited number of threads, we have to basically make sure that all our threads are working. All our threads should not be set ideal. They should be doing work. Now let's say some user is hitting this request. Okay, then imagine one thread is basically handling that particular request, but by the time these two things are done, this is getting very faster. But the calling thread, basically who is giving the work to this thread and this thread, it has to wait over here to complete this couple of things. Well, we are going asynchronous over here. The 8-second work or 6-second work we are doing in 3 seconds. But after that, what? After that also the thread need to be blocked. Over here, you are doing join over here, right? We're blocking that particular thread. If it is a kind of server we are using, if it is, imagine your Spring Boot, the thread we are blocking over here. And at end of the day, we're returning a product info. We're not returning a completable future here. You are not returning that. You are not doing, if you are not going to do join, okay? If you're going to do command option V, sorry, again, cancel. Control 1 here, product future, control 1, assign statement to a new local variable. Imagine this is a completable future, right? That means the value will come in future. This product info value is there, but it will come in future. You are not returning this. You are not returning this, right? If you remember in your Spring Boot style of coding, we always return a model object like product info directly, not completable future, right? Completable future, if you're returning, means what? We are saying, okay, thread, whoever calling this particular method, okay, make sure the product info data you will get in future. We're not telling that, right? What we are telling, we are going to return you a domain object all the time. You imagine whatever code that you have done, you remember all the type of coding that you have done, you always return a model object like this, right? You always do this dot join, and you're going to get the product info object directly. Okay, here you should get the product info, and here I should be returning a product info. 1 second. Right here, you're returning a product info here. Okay, that I think this one I can directly put it over here. Okay, I can assign it to over here and I can assign it over here. Now I'm returning a product info, but here, if I can return a completable future, that means the thread which is going to handle this request, the thread knows that, okay, I have made a call to this, but this value will come in future. That kind of thing we're not doing. We're not returning a completable future here. But in our reactive code right now, we'll understand how can we can, the thread which is going to handle to this method, we can tell to that thread, okay, you don't have to bother right now. You made a call, right? This data will be processed and will be given back to you in future, right? So you no need to you don't need to block over here. You don't need to block over here. You can go back to the thread pool again and help the other user request to process, right? Help processing the other user's request. You don't have to get blocked over here. So if we can return something reactive, something asynchronous, something completable future, or mono or flux. Okay, mono you don't know. If we can return a flux over here, where we are saying, okay, this data will come in future, something like a completable future, then that can be really good, right? And all this drama that we have done today is just to tell you that we can make non-blocking call over here and we can return something which is where the value will get in future, right? And that's something that we'll be learning in our Spring Web Flux session, and we're setting off all these things for that only. Okay, so you already know Flux. You might have seen some of the methods returning Flux. What do you mean by that? You have already know Flux, right? It's a publisher. So that thing we're going to be learning, right? So is the things making a little bit of sense right now? Do you are you guys able to connect what I'm trying to say? Guys, Alok, Swati?
Abhilash, like here, one question, Abhilash. Here, like here, I got the point. Like here, like we are giving the final result here in this like asynchronous way, like for compatible future way. In reactive, like we are returning the flux.
Yes. In React, that's what we'll be learning. I'm just giving you a kind of hint, Swati, that instead of product info, if we can return a completable future over here, you're blocking, right? You're blocking. You're saying, okay, make sure this future is complete. This future is complete. Grab the result, construct a new product info, and do join. That means I want to get this data whenever it's ready. Okay, and then you are grabbing this data, right? And then you are returning this. You are blocking the things over here. If you are not going to do join, then you can return a completable. You can get a completable future and you can return that. But comparing, for an example, if I are not doing join, okay, then I can get a completable future over here, right? That means this data will come in future. The product info data will come in future. One second, let me just change that to this. Let's say this is future and return this future over here. We can return this guy. Now you think this style of coding in your Spring programming, are you doing this style of coding, Swati?
Yeah, but this is not doing, but here in reactive we are going to do this way, right?
Yeah, exactly. Yeah. Yes.
But why can't we do like in Spring this way?
No, in Spring we can do that in that way using the Spring Web Flux, Swati. Okay.
No, yeah, in Web Flux, okay, Abhilash, like here in this way also compatible future.
Exactly, we can do. Yes, yeah, getting your question right now. We can do, but your code will be real messy. It's completely messy, Swati. You still can do that. I completely understand your questions right now. You can. This is a very simple example. Imagine this the product model have some more internal objects which are some kind of list or some kind of set that you need to grab by making another service call. Then end of the day, I will add some of the screenshot to this recording in case anytime if I'm going to post it, you can see the more you're going to write like this, your code will be keep on getting messy. And here I'm taking a very simple example. And your completable future is not giving is okay if you can do a join over here, you can get the data, right? If you're going to do join, that will be still be blocking in the previous approach, right? If you're going to write, still going to be writing completable future code, it will be completely messy, right? The reactive is going to provide you a good kind of API to deal this kind of coding style where you want to go non-blocking. Okay.
But this way also it is possible, but it seems like it is a messy, like and everything is messy. That is the only disadvantage, but it is possible with this approach.
There are also other disadvantages. As I haven't discussed about it, I am not able to explain that to you, Swati. But you think like this, the web server that we are using currently is Tomcat in Spring Boot, isn't it? And Tomcat basically not built to handle the asynchronous programming, something like this. It always works in a thread per request model. The diagram that I've shown you maybe 1 or 2 sessions before, if you remember, one request comes from the pool, we're taking one thread, and that thread responsibility is to take care of the complete request response cycle of that particular request, right? Now what we want is, if we can return a kind of future object, something like this, what we want is the thread, which is basically busy processing that particular user request, if that sees that, okay, there is something going on over here which is going to take time, it's going to immediately can go back to the pool, right? And then it can handle processing another request. If multiple concurrent requests are coming into your server, right, then you can manage, if you have only 100 threads or 200 threads available, then instead of blocking the things over here while processing this kind of task, you can reuse those threads processing the concurrent user request, isn't it, Swati?
Yes.
That is the main thing, and for that we have the native server. Okay, we won't go with the Tomcat. For reactive, we have our reactive server, and that will be much more powerful than the Tomcat. So that is something that we're going to be achieving. You always remember this thing as all this completable future, or your reactive, there is a manifesto or manifesto or something. Yeah, there is some kind of characteristics has been defined. Reactive, one second, manifesto. Yeah, you can see this. This diagram is applicable for your future also, your reactive programming also, your completable future also. If you're going to do asynchronous programming in Java, or if you're going to do asynchronous programming in any language, you just need to make sure you are following all these characteristics. Okay. First of all your reactive applications should be responsive. Okay. All your reactive applications should be elastic. All your reactive applications should be resilient. And all of your reactive applications should be message driven. This is the manifesto for all your asynchronous programming or your reactive programming. Maybe these terms, I don't know how many terms is making sense to you, but I am damn sure you can understand everything. Let me try explaining you. This responsiveness basically means the diagram that you have seen here. If you're gonna see that STS, this is what the responsiveness means, right? Non-blocking call. You make a call, right? Then the thread which is basically calling this code, okay, is giving that task to that particular thread and immediately return. It is not waiting for the execution for this line of code to complete. It immediately returns a value called future, which basically says that, okay, the value will come in future. Okay. So this is responsive. You're going to hit it. It's going to give you the response back immediately. It's not blocking your code, right? It's basically some REST call or DB call that you are making where the thread which is calling this thing, that is getting immediately returned. Okay, that is what you mean by responsiveness. You are getting responsive to the errors as well. Like this completable future, and basically I haven't discussed about this. The completable future has another advantage over the future API, which will help you to process the errors as well. Okay, so in your reactive stream also, whenever you'll be using project reactor, you will see the facilities for error handling as well, right? The responsive, your code should be responsive. If you're gonna hit my website should give you the result back, the response back immediately. Okay, otherwise nobody will use my website. The responsiveness. Okay, you can go to this website, you can also read whatever they have written for the responsive. The system responds in a timely manner, if at all possible, right? So that is one thing. The next thing, your reactive applications or your reactive manifesto says your application should be resilient. It should be tolerant to the errors, right? It doesn't mean that if there is some errors occurs in your system will break. No, your system should have the ability to process the error, to handle the error. It should be resilient, right? It should be elastic. Elastic means, let's say now I have. Moez, please be on mute.
Yes, sir.
No problem. Elastic means what? Let's say right now I have 10 users using my website, right? Suddenly my user grows to 100. Then my website should have the capability, my web server should have the capability to handle, elastically should handle, like a elastic, right? It should be able to grow, okay, according to the number of users trying to access my website, right? The thread pool that it manages, the thread can go up and down considering the number of users using my website. Okay, it should be elastic. Okay, and it should be message driven. Okay, my system should be actively looking for the messages. The communication happens through messages between systems here, right? And whenever there is a message arrives asynchronously, my application should be able to consume it. It should be message driven. Okay, we already spoken about the message driven architecture and how our observer pattern works. We already spoke about it. So our reactive application or asynchronous code, whenever we're doing, we're basically dealing with the message driven architecture, isn't it? So that's all about it. So this is what your reactive API, any reactive system that you're building, it should follow these characteristics. Okay.
How elastic is happening, Ablash? Like
you think about this thing, elastic thing. You think about this guy. One sec. Like thread pools only. See this line. Completable futures dot supply async method. You have written this. For example, I'm removing this get mapping thing. I think that discussion is done. Now look at this code. Okay. Now here you are doing completable future dot supply async. Are you managing the thread pool? Swati, are you creating thread? Are you managing the thread pool? No, right?
No, internally it is being.
It is internally. You can today after your call, you can go to this method and can log something like what is the current thread, and you can see internally this completable future is creating a fork join. It is using the fork join framework, and it is internally creating a common pool. Okay, and that pool it is creating the number of threads based on my need. And it can go up and down based on my needs. It has some default capacity, and I don't want to get into that. But thing is that here internally it's create a kind of thread pool, and I'm submitting my tags to one of the thread. So that is elastic. Okay. Now this is a non-blocking code. This is the example of responsiveness, right? Obviously, I'm not doing any error handling, but you can see there are a lot of methods over here, okay, which can help you to do error handling and to make your system resilient. Okay, so I don't want to get into this. And also the message driven, you understand, right? Whenever something happens, we'll be notifying. The reactive application will be notified. It will be actively looking for messages to flow and to come into that so that it can consume it. You can go to your reactive manifesto and can learn this. But most of the time, some people who doesn't have any work, just like me, right? In interview, they ask you, okay, tell me what is the reactive manifesto, right? Has nothing to do with the coding thing. You need to explain them what do you mean by responsive? What do you mean by elastic? what do you mean by resilient, and what do you mean by message driven, and all these 4 things, how it is connected with your reactive style of coding. But end of the day, if you know what is reactive programming, if you are doing coding, okay, you understand what it is. Okay, elastic, connected to the thread pool. Responsive, connected to the request response model. Immediately I should get a response, right? Now it should be pretty much responsive. My website should be respond to me in a timely manner. Resilient, it's all about the error handling part. My system, my reactive application should be able to handle the error. Otherwise, that's not a reactive application, right? If it doesn't able to handle error, that means it will fail. It will go down, right? In no second it will go down. If you're going to get 10, 20, 30 errors in the website, that's it. Okay, your website will go on hang, and people will be bashing you like anything, right? And message driven, you understand that everything happening over here is through messages, right? Now you go ahead and read all these things going into the website and understand everything. And as I said, the reactive, I think, is came in around 2013-14. There is a group of engineers from different company. They have found a way where they can go cloud and can utilize their resources, write code in a non-blocking fashion. They can be extremely reactive to the user events which are happening. Let's say you are scrolling your feeds in your Twitter feed. Okay, you are reacting to those application, you are asking for data, you're doing a lot of different things. How our application can be more reactive to the user events, and for that they come up with this reactive model of coding, right? And that is something that we are exploring from the last few days, and that's ends of our iteration 2. And in our next iteration, we'll be diving deeper into the project reactor, and we'll have around 4-5 sessions on that. And then welcome to the Spring Web Flux and the microservices using reactive. And for that, you guys are here. Not for the reactive Java, I know, but this is the basic. If I'm going to skip this, imagine we have around 8, 9, or 10 sessions. If we would have skipped this and directly jumped into the Web Flux, it might have been very difficult to grab and understand the thing. I feel so, but it's up to you. Like, how do you guys approach this? Yeah. So
actually, it's my bad. I missed the last part. Like, when we were doing the definition stuff in Reactive Manifesto, and we finally able to read the last part.
Moise, I think you're breaking off. Your voice is not that much of clear, maybe because of the microphone.
Are you able to hear me now?
Better.
Yeah, actually, I missed it's my bad. I missed the last part. Reactive Manifesto. Like,
don't worry, Moise. I'm gonna be pinging that website link. Just read it once. You're gonna be getting everything over there. Okay, don't worry.
Yeah, there, but your definitions make me understand more with that product for example.
Okay, thank you so much for that. But I'll make sure that if there is something I can do for you guys, as I said, I'll be doing that. So don't worry. I'm gonna be tracking the user attendance every day, and I know like who are using the thing. Are you going to post this recording, Namrata? I'm gonna be letting you guys know, but this recording are only going to be available to you guys. Okay, so I know like who are attending the sessions regularly, only to those guys, and there is no request from others. I know who are attending, who are by looking into their session time and the recording watching times, I know. So if you are hearing this recording for free, do not ask me for the recordings. This is a live only batch. As I said, I made it free for you guys to make sure like you guys can come and join, but I do not want to give the reactive Java sessions as part of your Spring course, and that's something that we have already decided to do. But if you are part of this journey, then obviously you're going to be getting the recording, and that too for free of cost. You don't have to do anything, you don't have to pay anything, you don't have to request me. You're going to be already seeing that, you will be seeing that thing in your account. I'm a little occupied right now. Once I'm back, the new course that I'll be creating on reactive Java, that will be accessible by all of you guys. Okay, don't worry. Okay,
Abhilash, when
Yes,
are you planning the next session?
Prajakta, for this week, no. Next week till Thursday or Friday, it will be very difficult for me to manage, Prajakta. Maybe from the next Friday, Saturday, it might back. Okay. And after the next 4-5 session on the Java Reactive, then I will take the Java Reactive sessions to a different time, or maybe a evening time. I'll give only slots to you guys. Okay. And then maybe we'll go DDD or some other design patterns in microservices. We'll start it in the morning, and the reactive thing we might keep it for a different batch only with you guys. Okay. Whenever you guys are available, I'll just discuss with you, and according to your availability, your time zone, I will be managing it. Okay.
Evening means what time, Abhilash?
I didn't plan, Swati. I'll discuss with you guys only. If you guys are not comfortable, I'll not do it. Okay. So, or we can go weekend. Okay. 2 sessions, 3 sessions per week will be enough, isn't it? See, once this is just a paradigm. This is just how the code works. Once that clicks in your mind, that's it, right? You understand what is what, right? And all these things are very easy. What basically difficult to digest in the beginning is why reactive, what we are trying to achieve, why they're writing code like this, what the heck is happening, and all these things will be a problem if we do not understand functional programming. Okay, so that's why I told you stream API is the first thing you understand. If you understand stream, you can understand this reactive streams, you can understand completable future, you can see like, okay, they're creating just a pipeline, right? But I know still a lot of you, and maybe a lot of you who are watching recordings, I'm talking to you guys daily, you're still stuck with legacy application. And guys, if it is 2022, 2020, I used to tell you guys, okay, no worries, keep on working on those applications, but right now is the right time to get out of it. Okay, because now the minimum requirement outside is Java 17, at least the Java 11. Okay, if they're not doing anything, they're at least using Java 1.8. And if you're working beyond or below 1.8 version, it's time to go out of it. Okay, so maybe think about the switch, or maybe a project change. This is not going to work anymore, so be comfortable with the functional style of programming. Okay, that's it, guys. See you guys then on whatever day, I don't know, I'll announce it. And I will be busy with that wedding thing from today onwards. And guys, please help each other, huh? In whatever groups that you are part of, if there is any questions, please help each other. And I will try to connect you guys. Like I don't think I'll be able to afford time, but if I can, I'll surely do. Okay, there are still some pending calls. I'll try to take those. But yeah, I'll let you guys know. Okay, that ends off the reactive Java iteration 2. Okay. See you guys in the next session. Bye-bye.
Bye, Abhilash.
Bye. Have a good day, guys. Take care.
Thank you, Abhilash.
Thank you.
Thank you, Abhilash. Bye.
Thank you, Swati. Bye. Thank you.